Hey everyone, in this video lesson we will understand everything about Apache Airflow, as Apache Airflow is very essential when you go and work as a data engineer. So Airflow is used to orchestrate, run and manage your data pipelines, right? So let's start with the agenda, what all things we will be discussing in today's lesson. So we will be starting the lesson with basics of Airflow. We will understand everything about Airflow. Then we will go into the architecture of Airflow. Then we will understand how Airflow and Data Factory are similar and are different altogether, right? Then we will start understanding what is DAG, the Airflow UI interface. Then we will understand Azure Managed Hosting of Airflow, right? We will start looking into the deployment of Airflow on Azure Cloud. At the end, we'll give you a hands-on sample program which you guys can practice at your end. Let's start the session. Before we begin the video, a quick information guys. If you are planning to start your career or switch your career in data engineering domain, we at Apache Learning offers the best data engineer program where we cover all the skills which are mentioned in job descriptions, starting from Python for data engineering, data warehousing fundamentals, Azure Cloud, Fabric Cloud, PySpark, Databricks, Snowflake, Airflow, and Kafka. The best part is it's a live online weekend training sessions. Check out the program details for more information. Let's start the video.
So some of you may already know a little bit about Airflow, okay? And some of you might have seen this already in the data factory. Yeah, the plugin is available in the data factory. Yeah, this gained momentum very recently. Airflow picked up momentum very recently, and within no time they became very popular. And everybody on the data engineering side, they simply love it. Okay, even I personally like them, Airflows. Okay, we'll see why. How did they so quickly made it into this data engineering stream? Okay, so first thing to begin with, right, for any tool to quickly become popular, it has to be an open source, right? Not always if it is on the Apache Foundation, right? So this is Apache One open source platform. It's available for anyone. Just like Spark, you can download, install locally on your system or server and write PySpark programs and do data transformations on big data, right? It's very much possible with Airflow also. You can download, set up locally, and without touching any cloud, fully available to download and install and work with. But you, if you're downloading and installing it on your local system, you should provide it the computing power. Okay. But if you don't want to do that, then there are managed services available on Azure or on AWS. Okay. Or Airflow Foundation itself, they have managed services. Just like Spark. Spark is offered on Databricks. Databricks in turn is offered on Azure and AWS. And if you don't want Databricks, Spark is offered as is with in HD Insights. Now, how Airflow started is, I think that Air, you see in the Airflow, has come from the Airbnb. Okay, so Airbnb as an organization, when they were trying to figure out how they can schedule their scripts. Okay, schedule their scripts. It all started with very basic requirement like that. Okay, schedule their scripts. They have explored many schedulers available in the market, but they were not very robust, especially when your entire workflow is in scripts, just in simple scripts. Okay, so then they created their own scheduler, which started as a scheduler. Then they added so many things to it, and later on Apache took over, and you got the open community sponsorship for this. So in 2009 it became an independent project. Okay, it's no more with Airbnb, but yeah, those guys are the initial contributors to this platform. Scalability and complexity, these are not very native to Airflow. Scalability depends upon the cluster you allocate to this, the hardware resources to Airflow, okay, the hardware that you provide, and the complexity, the workflows, the data processing load that it can take comes from the Python programming. Okay, so Airflows is natively developed on Python, and any program that you want to run on the Airflow should be a Python program. Okay, Bash is also supported. So all the complexity happens on the Python side. So because Python is readily integrated with it, you can handle with Python, there's no limitation. You can do any scenario, any data processing scenario. That's now these two gives the actual power to the Airflow. So you have this extensive usage because you can write the programs in Python. Python can talk to APIs, databases, files, yeah, external interfaces, whatever it be. Yes. The good part with Airflow is that they have a very user-rich interface. Okay, so I'll just show you the sample how the user interface looks like. So this is the user interface. There's different programs. Okay, so they have very good user interface, better than Spark. Okay, this user interface is much better than Spark. Spark also has this user interface, but yeah, this is definitely better than that, and that is given free for you. And ability to connect with any system, right? So this is available almost all platforms now. But as in previous stage only, they are not fully bringing them into their. I'll tell you why they're doing that also. And it has its own scheduler. You'd compare it with Spark. Spark doesn't have a scheduler. Data Factory has a scheduler. Yeah? Triggers provide the scheduling ability. Here also in the Airflow, it has its own scheduler. Actually, to begin with, it was a scheduling tool. Okay, what do we do with Airflow? We have understood that it's an open source platform. It does the scheduling and then it runs the Python programs. But what is it actually used for? Okay, so this orchestration tool, Airflow, is also used for ETL, okay? Whether it is real-time streaming or batch processing. It can handle both. But if you ask me, does Airflow does it? No. The program that you write in the Python, just like the program you write in PySpark notebook. So here the program you actually write using Python program. That program, if it can handle real-time data or batch data, can very much be executed, maintained, scheduled using Airflow, okay? You might be wondering if all the code logic processing happens in the Python and Airflow is just a scheduler which will run the program fixed intervals, report failures, give you options for retrying. What is that value addition Airflow is doing? Wouldn't it become just another scheduler? For if you're working on machine learning modules, right? You'll have to do a lot of rerunning, lot of failures will come. You have to retrain your model. Yeah, this would be a good tool to generate that. Daily report generation, orchestration of complex systems, IoT integrations, right? All these places, Airflows can be used. So what is that actual difference between Data Factory and Airflow? Or can we actually compare these two? Can we compare Airflow with Data Factory? The answer is yes. We can compare these two. Okay. So Data Factory is close to Airflow, but it's different in some ways. So let's understand that. This will be an interesting comparison. Okay, so the core functionality. Yeah, let's draw a difference between these two to understand Airflow a little better. Azure is not an open source platform, right? But it is kind of open source only. Why? Because they don't charge anything for developing pipelines or data sets or creating link service, anything on the Data Factory. Okay. Even after developing, the resting cost is also not there with Data Factory. The charge only comes when you run the pipelines using that DDU model, or if it is data flows, then the cluster, that node pricing. Okay. But so here is also the same thing for developing your DAGs and then posting them, uploading them, working with Airflows. It's completely free. Yeah, no cost. But when you run them, when you schedule them, you need some hardware resources to run that program. That's where the cost comes. If you're locally doing it, you're locally providing the hardware. If you're doing it on the cloud platforms, then you would be paying for the cloud infrastructure. But the difference is you can edit the source code of Airflows. You cannot edit the source code of Data Factory. I think sooner they may make Data Factory also open source. But at least for now, Data Factory is proprietary and Apache is open source. Both of them, still the development is free. Only when you run them, the cost incurs. Integration, right? So Apache Airflow, being open source platform, is available in all major cloud platforms, so easily integratable and available with any system, any ecosystem. But Azure Data Factory is available only on the Azure ecosystem. Customizability. This is the one of the key distinguisher. You have high customizability because you can write the scripts directly. When you get the right script writing, you have this. But in Data Factory, you don't have that. It's all graphical. Okay. Even in data flows also, you don't write any. The flip side is for smaller activities, it will take more time if you're going with Apache Airflow. The same customizability may become a little bottleneck for smaller activities because graphical user interfaces quickly you can turn around a solution. Okay, so that may take time for simpler solutions. Second thing that you have to note here is though Data Factory is fully graphical user interface, still you can run the scripts. You can run Python scripts, you can run Java scripts, you can run PySpark scripts. Okay, using external activities. They have plugins for Databricks, for Azure Functions, for Azure App Services, for Azure Batch Services. Okay, so even the logic apps using external platforms like that, you can run the scripts in Data Factory also. But if you ask, can I run the scripts directly in the Data Factory? No, but they have these connectors which you can use for yeah. In Apache Airflow, you can run the scripts directly within it. You don't need any external connectors for it. Python scripts or Bash scripts can directly run inside the Airflow. Scalability, in both the cases, it depends upon the infrastructure you are attaching to these applications. Yeah. If you are locally hosting Airflows, then you'll have to do a lot of work in the infrastructure wise. But if you host the Airflows on Azure Data Factory, just like how Azure Data Factory can get advantage of the TTUs, which can be scaled very quickly, yeah, automatically, like that, Apache Airflow infrastructure can be scaled quickly. But if you're doing locally, then you'll have restrictions there, you'll have problems. Pricing model for development, no cost. Here also for development, no cost, just the infrastructure cost will be associated. DAG, directed acyclic graph. This is little different here. You might have come across this. Can anybody tell me where did you come across this? Stage. Correct. Each stage is a DAG. But underlying concept is still same. That's why it is called DAG. You have your data factory. This is the data factory studio, correct? So if you are working with Airflows in Azure, so if you open the data factory resource, right, you will be asked to launch this data factory studio. This is the IDE where you do the development, not just the development, scheduling and monitoring also. Yeah, the same studio is used for scheduling your pipelines and monitor them also. Correct? That's a studio for data factory, right? Just like that, you have a studio for Airflows, and that studio is called web interface. So the one that I showed you earlier, this one, this is the web interface for Airflows. Okay. Here you have much graphical interface for development also. You can create pipelines, data set, link services, all of that, right? But in this Airflow Studio, you don't have that. The other functionality like scheduling, creating triggers and setting up the schedules for the triggers and monitoring them, monitoring the last runs, gathering the statistics, failure statistics, or statistics, that all possible in this studio. All of that are possible in this studio. User access management is also there in this Airflow Studio, but we don't do that if you are going with Azure because we will integrate with Azure AD, Microsoft AD, so you don't have to set up independent users. So now, if you want to work with Airflow in Azure, you will set it up within Azure Data Factory. So you will have to launch the studio. So when you launch the studio, right, you get this. So you have the regular stuff, whatever we have done, right? Then in the manage section under integration runtimes, okay, I created one because it takes time to come up. So I'll show you, but how to create this. Okay. So it's very simple. So you'll go to the integration runtime section, and then here you will click new, and then you will get this option to create Airflow integration runtime. This Airflow integration runtime will allow you to run Airflow objects or Python scripts. And that in turn will give you access to that web interface, Airflow web interface, where you can monitor the schedules. Okay. So you select it and then click continue. Okay. So you'll have to give us a name to it. I've given this Airflow IR001, and then it'll ask you whether you want to integrate with Microsoft AD or go with the basic one. So in the basic one, you will have to create one admin user password, and for the more people where you want to give access, the rest of the things will be set up here inside the Airflow interface, web interface. But I would recommend integrate with Active Directory so you can use your managed identities, rest of the ones, all of those ones, yeah, with the data fact airflows. And this is where the cost happens. You want the small one or you want the large one, scheduler, the server on which your scripts will be running. Okay. So this node is different from the node you have seen in the Databricks. Even there also you'll select the cluster. Okay. This is not exactly a cluster. Okay. So this is server client architecture. You'll have one server and 6 clients. So 6 workers means 6 clients. Okay. And 3 schedulers. We will discuss that later. Exactly. And you want scaling, auto scaling, you can do that. Choose small, it's enough for our exercises. Airflow version, this is the latest version available. But remember, this would be one version back always, because they would be supporting the last stable version. If you want the current version to work with Airflow, then you will have to probably go directly with them, Airflow. But with through Azure, will be one version back. Same thing happens with your Spark in Azure Synapse Analytics. In case you want to create any environment variables, yeah, or overwrite any Spark configurations, you can do that. You can do these things later also. Add any Airflow requirements, you should do this. So you should add one package compulsory here. That package will add the Azure compatible functions to the Airflow libraries. Okay. So that package will enable your scripts to run in the Airflows. Okay, I'll tell you which one is that. Part of Apache Foundation, fully approved by them. Apache Airflow providers for Microsoft Azure. Okay, it's part of Airflow Foundation. So this package, this Airflow providers for Microsoft Azure should be added to the base libraries. This should be added to the base library. So this package will be imported into this cluster. We don't call this cluster, this compute node. Okay. So it will be imported so your Azure related functions can work. You can actually call Azure pipelines also using Airflows, data factory pipelines. So all that compatibility will be provided to you. Okay. If you have any secrets, you can. So once you configure this these basic settings, okay, this is important. Once you do this, you can do this adding Airflow requirements or environment variables, configuration overrides later also. So if you want, you can enable Git sync. So this, whatever the configurations you do will be committed to the Git. Otherwise, if you don't check this, this particular integration runtime will not be committed to the Git. Okay, it will be available only local. Now, once you install the IR, the Airflow's IR, then this workflow orchestration manager will start showing up here. Then if you click that, then this will take you to workflow orchestration manager instance. Okay, this is the instance. Right? You see, this is the large node. This is the latest version of the Airflow authorization, Azure Active Directory, AAD, and this is the region we have hosted. So you have multiple options here. You can monitor. Monitor will take you to that interface, or you can edit here also. So when you click on edit, the same IR will come up. IR properties will come up, so you can edit them.
Hello.
Or so once you have that integration runtime, then you get this managed instance. Okay. Now, so you only have the runtime. Okay. So now you need programs to run on that runtime. Okay. So those programs should be Python scripts. So I'll now go and talk about the Python scripts. Okay. Then we will come back here. How and how the Python scripts are executed on the Airflow, we'll discuss now. So the Python programs that you will be creating in order to run them on the airflows, right? They are called DAGs, directed acyclic graph. So what does that mean is, in your Python program, the file should have well-defined tasks, okay? And these tasks will be sequenced. So each task is a edge, and the sequence in which they should be executed is a vertex. Okay. So that's why it's called graph, okay? Because it's when you submit the program converts that script into tasks and then the dependencies between the tasks. So the tasks themselves are vertices. I think I might be saying it in reverse. And the connectors between them are edges. Now, that's why it's called graph, vertices and edges. And it is acyclic because if once a task is created, you will not go back and run the same task again. It will not be, it will be always forward sequence, forward workflow. Okay, it's always forward. One action is complete, then it is passing on the information to the next action. An action can go in loop, but once the loop is over, it will come out, pass on the control to the next action. Okay, next task. Task can run in parallel like this, or they can run in sequence like this, or there can be a dependency also. For example, this task D should be started only if B and C are complete. And E will start only when D is complete. But there will not be at any point in time backward flow. That's why it's not cyclic, it's acyclic. Okay, it will not go on like the A, B, C, the A, B, C. It will not go like that. Okay, so that's why it's acyclic, it's not cyclic. Directed because there's a direction between each task. Okay, so altogether it's called DAG. Now let's see how is this DAG implemented. For that, I'll show you some Python scripts. So I'll take one sample Python program to show you how this is all done. I'll also tell you how this all set up to be done in order for you to run this program. But for now, just watch my screen. Okay, you don't have to do anything. Just stop it what you're doing, yeah, and watch my screen. So this is a basic Python script. Now, in this Python script, there will be two things. The actual work that you will do as part of your ETL. Okay, the actual work that has to be done as part of your ETL. Second, the task planning that should be scheduled on the Airflow. Okay, so for example, I want to do 3 actions. I want to write a sample Python program which does 3 simple actions. What you will do, you will import some Python packages, then functions, some lines, then you will go in your main method, and then function, and then maybe some more lines, and then the program is over. Print something. Right. This is your sample .py program file. Now the same one. So you have not just one function. You have function one. Then let's say I'll just write it here side by function 2 and function 3. Yeah, 3 functions are there, and you're calling all those functions and you're returning something. So now this will be converted to DAG, directed acyclic graph. Now DAG is also a Python program, just like your regular PY. Okay. All that actions you do, okay, will be created as task. Task 1 is your function 1. Task 2, you'll assign task 2 to the function 2. Task 3 to function 3. Then you will call task 1 followed by task 2 followed by task. Okay. So this is where the DAG comes. Okay. You are setting the execution order for these tasks. They should be executed only in this order. Okay. When you do this, for doing this, you will have to import DAG library from Airflow package. Okay, you'll have to download DAG libraries from Airflow package. Okay, then you get to create these tasks and then set the sequence for these tasks. So if you do this in your Python program, in addition to the regular activities, the functions they need to carry the actual work, then your PY becomes a DAG. Okay, you see the difference between this and this. In this, you don't have tasks, and then you don't have sequence. You would be probably calling your functions just like this, no sequencing, just based on the action. But the problem is you cannot set dependencies. You can do, but it would be a lot of other programming is needed if you have to set dependencies and or run a couple of functions in sequence. Okay? But you can do that here seamlessly because you are assigning each function to a task. So each task will, if I have to dock parallels, this task is an activity. Like you have activities in data factory, then whatever the dependencies you set here, this is the flow, cycle flow, a cyclic flow. Okay, that becomes a tag. So if you see, go back to this Python program. What I'm doing is I'm importing some time-based functions. These are regular Python packages. Then from Airflow, I am downloading the DAG library and also bash operator because I'll be actually doing bash code. Okay, bash functions, not the Python functions, but the bash. So that means this is not a py. In this case, this is dot bash. Okay, some command 1, command 2, command 3. Now these will be converted into a DAG with the Python wrap. So if you see, this echo task 1 is one command, echo task 2 is another command, echo when task 3, when 1 and 2 are finished. Both have to be finished for task 3. Okay, that is your third bash. But you're wrapping those bash commands within this Python program. So this becomes a Python program. And this becomes a Python program DAG, directed acyclic graph, because you see these functions I am assigning to tasks. These functions I might assess, and I'm providing the DAG object. Because I provide a DAG object, these will be considered as independent function. Now, what? So half part of the task is your actual code, what you are supposed to do, and then the remaining is the DAG object. Now, what is this DAG object? This is the DAG object. This you do for Airflow. Okay, so you will set the name of the DAG. Yeah, each DAG is one job for Airflow. You will set the name, then you will pass some default arguments. Those default arguments would be like this: when this DAG should run, okay, how many times it should restart, in case of failure, to whom the email should be sent, additional configurations, some description, okay, how frequently you want to run this. That's it, the scheduling information, and then there's some configuration information. Now this object will be connected to each task. So this is your regular program, what has to be done, and this is the DAG connectivity part. Now once you do that, then these three tasks can be sequenced like this. If you do like this, that means first you run task 1, follow it by task 2, then you start task 1 and task 2 in sequence, and once both are complete, so this is forward dependency. Okay, this means the previous two should be complete. Then you go for task. Many other ways in which this can be done. If you go a little deeper, more into the DAG, you will understand this. Okay. So what I have done is I have taken a basic example to showcase how the regular basic program is converted into a DAG. Now you have this. This can be executed on the Airflow. Airflow. Then once you give this DAG, it will identify each this task as an independent activity, and it will run each task independently, and it will create this connection that only on success the next tasks will be run. Anywhere it occurs a failure, it will give you the option to retry, not the retry that you see here, but the retry on the Airflow level. Okay, now that I have the tag, so this development doesn't happen in the Airflow. This whatever I have created here, this will not happen on the Airflow. This will happen in your local Visual Studio Code. We use Visual Studio Code for Python programming. Even all this is an open source tool. We have seen this earlier also. So all the DAG preparation, the actual coding in Python, everything happens locally or on a client system using Visual Studio Code. And once your DAG file is ready, sometimes it so can happen that your actual code may not be this simple, one-liner. Okay, the actual work you do as part of the ETL may be like 100, 200 lines of code. So what you will do, you'll create it as a separate file and then import it here, that file name from, you will have to create it as a class from the file name, provided it's in the same folder. Okay, it should be in the same folder, file name, import class name. Okay, then for that class, you create an object, you can access all the methods in that. If you don't want to define class name, you can directly import function also and then use that function here. Yeah. Or if your code is simple, then you can put it in single file, the DAG file itself. This is the first part. We will see some other DAGs also. For starters, let's now the next task is you have to bring this DAG into this Airflow web interface. So you'll have to bring that into Airflow web interface. Here, you see these DAGs, these all were imported. But how do you do that? You cannot do that directly from here. So what you do is you go back to your managed instance, this Apache Airflow managed instance. And if you go here, you will find this option to import files. When it says import files, it means DAGs. Okay. So if you click on that, it'll ask you to link to Azure storage account where all your DAGs are present. So you already created some linked services to your storage account. So we can use one of the storage account. I used one of the storage account. Okay. Created a container. Simple process. Okay. Create a container Airflow, and in that create a folder called DAGs. This folder has to be named specifically like this, okay, DAGs, with this name only. Create a folder with DAGs and then place all your DAG files here, okay, .py files here. And once you have them there, then you can go back to your Data Factory Airflow instance, select the link service where the DAG files are present, browse to the folder path, Airflow. Don't select this folder, just click OK. It will automatically take the DAGs folder, right? People who are working on the Python programming, they know if they have to import a lot of libraries into the virtual environment they're working, they will write here, they'll create requirements file and then load that into the environment. If that is the case, you can connect that requirement file here. And now once you click OK, so all those files will be imported. So you will not see them here or anywhere in the data factory. But if you go to the web interface, right? If you click on this monitor, it will take you to the web interface. Now in the web interface, you will see those DAGs. This is the one we uploaded. It's a simple bash DAG. This is the title that you gave here. Okay. So it doesn't take the file name. File name is this, but it takes the title that you have given in the DAG object. Okay. So that it shows here. Then now if I go open this DAG file, right, I can see the code here also. DAG arguments, then the DAG object, then those three tasks, bash tasks, and then the sequence. Okay, this is a complete program, but it doesn't allow you to write anything or edit it here. Okay, and now see the beauty. If I switch it to the graph mode, I'll see the tasks. These are the three tasks: print hello, print world, print done, which are this: print hello, first task title, print world, second task title, done, third task title. Okay, each three tasks are identified. This is what I was telling you. Your file will not just be treated as one external file and ran on the Airflow. If you break your ETL flow into tasks and sequence them, Airflow understands it and then shows each task, okay, separately. Now, you might be seeing some boxes here. This is the task life cycle. We will discuss this task life cycle a little later. Okay. Now what I will do is I will go and run this DAG. So now I have all the DAGs, right? Now this DAG I will trigger. So I did one sample run. Now I'm doing the second run. Okay. It's running, succeeded. See, this run happened just now. The other two happened little later, little earlier in the day. But yeah, this run happened now. Now I can see this is a DAG. DAG is like a job. Now I can see the job run ID. This is the run ID assigned to this run. Now I can see the audit log, but I would be more interested in task level status. You see, three tasks are executed: hello world, hello, then world, and then done. Now if I switch to the graph mode, right, for each task, I can see log in the log. If I go done with task 3 after task 1 and 2 has finished. This is something that's coming from code. These are the logs now, detailed logs for hello world, hello from task 1, right? So you see three tasks which are programmed in the DAG are executed exactly in that sequence, and all three are success. All three or success, when it started, when it ended, right? Now, if I want to see today, it ran 3 times and 3 times it succeeded. Back to DAG level view. So you have multiple DAGs, right? So 3 tasks completed. So 3 runs completed. Okay, 3 runs, and each run has the 3 tasks. They all happen on the same day. This is today. Okay. Now we can do many other things: administration, creating users, and there is one database also which supports everything. Now what I will do, I will go back to the presentation, talk about the architecture of Airflow. So this is the overall architecture of Airflow. These are the components that Airflow has. Okay. So your DAG directory. Now this can come from on-premise folder, or if it is locally installed. If it is it's a managed service like we are using it in Azure, it should come from data lake. In our use case scenario, this is coming from, I would rather say, Azure storage, because the data lake is not required. Those DAG files can exist as blobs in the blob container. Azure storage. So these are the Python files. Okay, these are the Python files. Then you have this compute node, which consists of one web server, multiple workers, and schedulers. Now, this can be scaled up. This is called horizontal scaling. Okay, you can attach multiple workers. Yeah, the scheduler will pick up the workers which are free on round robin basis, and then allocate work to them, execute your DAG on them. Okay, and scheduler also does the scheduling, right? So based on the time that you give, frequency. Okay, and this is where the data sets live, external metadata to resolve conflicts or anything related to the graphs, DAGs. Okay, and this is UI, user interface. Okay, where we see the logs, run stats, run times, authorization, administration. Yeah, we have just understood what is that, right? Now, you see, this is one task. We have created 3 tasks, no? Yeah, one, but it's not in this order. So you have task one, then task two. Once both are complete, then task three, right? That's one graph. These 3 tasks are one. So I have added small description of what is scheduler, what is web server, what is executor. One thing that's important is executor. Okay. So what does this executor mean? If you notice this tag, here we are using bash operator. So that means you are running bash commands. Similarly, if it is a Python program, say I have a sample Python program, you will use Python operator to run the Python code. So whether it is Python code or bash code, they're finally, when you create the tag, they're wrapped inside the Python code. Okay. But specifically, if you're running Python code as part of the task, each task, then you will use respective operators. So this is where they have the ability to use something like celery executor, which can execute tasks on multiple workers. So distributed tasks can be done. Even I have not explored it, so I cannot comment more on that. But that's a possibility. We usually use the Python executor. Sorry, worker is a node. Okay, on the worker, the executor is a program, the individual task, which will be work, which will be uh, which will be processed with a set of data. It's more like see, you have this in Databricks cluster, you have driver node and worker nodes.
Yeah.
Within the worker, again you have the executors, which executors will be doing a specific task on a partition of data, and then the action, the program, right?
Yeah.
It's like that. So your worker is your node. On that node, the program, the executor, the actual program will be executed. The scheduler will execute the program on the worker course. They can do sequentially, they can do parallelly based on how your DAG is set up.
Okay.
Because in case you want to do some, okay, so let's go back. We will now discuss we'll see how to do the hands-on. First, what you have to do is you have to create one local Python environment to first manually run these programs and test them before you upload them as DAGs. Because on the Airflow or on the Azure, you cannot do anything. You cannot create DAGs or you cannot test them. You cannot debug them. For all those purposes, you need the Visual Studio Code. Because you all have already Visual Studio Code, what I will ask you to do is, you can do hands-on now. Okay. So these files are already available. You all have access to, okay, people who have newly come, they may not have access to this file base. This is a file base I was talking about. So we'll discuss about others later. So go into the Airflow folder and you have DAGs here. So these are the DAGs. First, we'll locally open them in the Visual Studio Code, run them there. Then we will upload them to the Azure storage account. And from there, we will import them into the Airflow UI. And there we will run them. Here is the link. I would suggest you create one virtual environment. Okay, one virtual environment, so you can import Airflow package into that environment. So create one folder. Okay, inside that folder, create one Airflow. So you do like this. Go into your Visual Studio Code. You can do along with me. Click on new file. Okay, or you can click on like this new folder here, and inside the folder you create a new file. But before that, open the terminal. Okay, you have the terminal, right? Navigate to current directory. Go to the directory. This directory can be anything. This is not Windows terminal. This is okay. Now go in that directory. Create one virtual environment. You can create virtual environment. I have given the commands here. Airflow Python setup for your on-premise. Okay, in order to create DAGs and debug them. So create one virtual environment, because Python 3 is the one installed. You can give any name like this. It will create a virtual environment with the name you want. Okay, here you give the name you want, my virtual environment. And then once it is created, activate it. So you can activate this with this command. This is for Linux systems. If it is Windows systems, it will be a little different. The major version, right? 3.10. Then you do pip. So you have this full command, which you will have to execute in order to install the Airflow package. So this is 3.10 because that's the version of your Python. If you have 3.6 or 3.8, you'll have to change this. 3, of course, for everyone it will be 3 only. Right now we are major version. 3.10, this comes from the version, whatever the version you have, that should be replaced here. Okay. And this pip install. If pip itself is not there, you can install the pip first. Okay. So using pip, you can install the Airflow package. Okay. I already installed. So when you install this, this will be installed in this virtual environment. So if I go libraries, you see I have Airflow library.
Do you need to install the Airflow with the constraints that you had? No.
Do I have to install what? Sorry.
You have the constraints like in the one you installed. Are those important? Are those ones important when we install,
yes.
or it doesn't matter?
Yes. This constraints important. Yeah. 2.8. You're referring to this one only, right?
Yes.
Yeah, they're important. This is the main package, Apache Airflow. Once you are done with this, right? Once your virtual environment is ready and the Airflow package is installed, then now this is the Python tag, name of the file. Because I'm already in that, okay, I'm not in that directory. I'm in the bin directory. So let me change it.
Already, if you go one step back, it's just gonna be in the VNV folder or directory. You do a cd dot.
I went into the root directory. Right? Okay, no problem. Do I have Python home reference here? Directly give the fully qualified path of the hit it. So you see the program successfully completed. Okay, the program successfully completed. You don't see anything printed here. Even if you are calling the py DAG, right? It doesn't print anything here because when you are using the DAG task, okay. So when you are using the DAG task, it will be giving the output to the DAG console, not to your local terminal. Okay, nothing will come to your local terminal. So when you run this, unless there's a failure or you explicitly print something to the terminal, it won't show anything here. Yeah, this print hello or print world. You see what is happening here? You have three Python functions. Okay, these three functions are called from three different tasks. Print hello is your first function. Then print world is your second function. Now each function is a task. Okay, so the task definition we are not doing inside the task. We are doing that in a function and we are calling that function by name in a task. Okay. Now you see like this also you can set up a dependency for task 3 which should be invoked only if 1 and 2 are complete. Okay. And in this way also you can set. This is one way. So this is one way of doing that. The simplified version. But yeah, this can also be done. Now this DAG is created, right? If I go, because the same Python DAG is available here. The second run we are doing 3 runs. This run just now completed. If I see the log of the first task, hello from task 1, right? So similarly, if you see the logs of task 2 and task 3, whatever we are sending out from there, it will go and print it on the terminal of the Airflow. Okay. So you author your DAGs or your actual ETL locally using Visual Studio Code. Okay, you'll be using Visual Studio Code. Yeah, latest version. This is an freely available IDE for everyone. Everybody was working on open source, but yeah, you can use other ones also like PyCharm, other IDEs also. Once you write the program, authoring is complete, then you'll upload these DAG files to the blob container. Now, how do you do that? So you'll have to take help of Azure Storage Explorer. We have seen this earlier, right? So first create a container inside your storage account with name Airflow demo or Airflow samples, yeah, files. And in that, you will not be able to create a folder here because this is not data lake storage account. So what you do, you use your storage explorer to create a directory, okay, new folder specifically with this name, DAGs. And inside that, upload these DAG files. Okay. And once you do that, you can verify that by going into the storage account and seeing them here. Right. After that, you know what to be done. You import them into your workflow manager, Airflow manager, by clicking here, import files, selecting that storage account and the container. Don't select the file path up to the DAGs, just the container, and import. Those files should be available there. Any questions here?
What does VS Code do? What job does it do? Because from my understanding, we basically like download the folder. Like we have the Python script in the folder already, right? And that folder is what we upload into the storage. So what's the purpose of the VS Code?
For
Since we have
authoring
the folder
your
already.
scripts. For authoring them.
Oh, got it. Makes sense. So it's basically to build the script out and alter.
Correct.
Got it. Makes sense.
Okay, after importing, where we have to run?
Yeah, after
I think you were nicely summarizing the flow. I think if you can continue a little bit more, it will be great. I think you nicely summarized.
Okay. Yeah. So after importing, then you will have to click on the monitor.
Okay.
So that monitor will take you to the Airflow interface, web interface, and it will reflect, it will show all those 3 DAGs which are coming from the storage account. So I have one simple program here which does more than printing hello statements. So you might be interested, you all should be doing this. Okay. You see this program, what it does is I have 3 functions here. Okay, this program is also available on that folder. So it, in the first function, it generates a series of numbers. Okay, it generates series of numbers. Let me actually do that. So if it is non-DAG, then you will not have all this. So you have just 3 functions. Because you don't have all that, you don't need these 2 also to be imported. So what these 3 functions do is, the first function generates a series of numbers. Okay, actually I cannot get away from them. Okay, if I have to, then I'll have to take out this XCOM push also, which connects these 2. Okay, so I'll not try to run them without this. It will take time to clean them up and everything. So I'll go back, put them the way they are. First I'll explain. I'll do that once you start hands-on. Okay, first I'll explain what we are doing. First I'll generate a list of numbers. So this is a simple list. Okay. It's a simple list. It generates a series of numbers. Now that list, which is generated in the task 1, assuming that this function is first task, will be sent to the second task. Okay, so you see the second task calling the generate data, that's in the first task. So this data will then be a list of numbers. Okay, on that list, I'll do square of each number and store it as another list. This processed data is my second list. I have these 3 tasks. This is my task 1, this is my task 2, and this is my task 3. In task 1, I'm generating data. This is a list of some numbers. Then in the second task, I'm doing square of each list item that generated in the previous task. Then in the third task, I am adding up all those numbers. So I'll get a single result. If I have a code like this, I would get something output like this. This is my first task output, a series of 10 numbers. Then the second task output is square of each of that number. Again, list output only. The third is sum of all those squares. Is this clear? What exactly I'm doing in these 3 tasks? So the trick part is now inside the DAG, the output of one task should be sent to the second task. Then I can do subsequent tasks. So this is how I push the data. The rest of the task creation is same as the previous one. I'll just call the function 3 tasks. This is the name of the first task. I can even say T1, T2, T3, A1, A2, A3, like that. And then this is a sequence. Here, nothing is parallel. Everything is sequential. 1 should be done for 2 to do, 2 to start. 2 should be done for 3 to start. Now, this DAG, if I run through Airflow, this is a basic data pipeline DAG. This name is coming from the DAG title. Okay, so now let's run this, trigger this. On the initially we did that on the Visual Studio Code, so this is not on Azure. Now I'll do it on the Airflow, but the server is provided by Azure in the back. Give me a minute. So what I will do is, okay, first let's go and check the output of that DAG. So this completed successfully. 2 runs we did so far. The second run happened just now. So I'll go and see the run statistics. So if I aggregate data, so first let's see the generate data log. So you see this is the data generated. This is the second task output, squares of same numbers. Actually, if you hover your mouse onto the tab, it will tell you run ID, how much time it took, and everything. Yeah, so these are writing to the console directly, but the real-time jobs would be dropping data to somewhere, data lake, or writing to some database. Yeah. So successfully it's completed. What I will do is I will put down the hands-on steps here. So what you should do is first install Visual Studio Code, then set up virtual environment and install Airflow package. Then create DAG files. Then upload DAG files to blob container DAGs folder. Then import container into what is it called workflow orchestration manager inside Studio. Actually, you have to install integration runtime inside ADF. After that, import the container. Then go to Airflow monitor. So you see here, this is your storage account, right?